this class. For this particular lesson, we're going to learn about methods in Java programming. Methods are very important in programming. Therefore, more of the time will be spent on explaining how they could be implemented practically in Java. But for this particular lesson, we want to learn to know exactly what methods are. You must know the advantages or the significance of having to deploy methods in the application. We could have possibly maybe do away with that. Why do we need to implement methods in our program? Okay, and quite apart from looking at the advantages, we'll also be looking at void and then return type methods. In the previous lessons, I had mentioned two major types of methods, that is static and non-static methods. But in this particular case, we'll be looking at void and then return type methods. And then return type methods or value. Let me simply put value return methods instead of return type methods. Let me put it right that way. Value return methods and then void methods. Okay, some methods are supposed to upon the call pass on the value, some do not pass on the value. That would be the clear distinction between the void and then the value return methods. Okay, and then in its conclusion, then we look at the parts of a method. Okay, then we end this video. Okay, so quickly, what are methods? In the previous code, we have been learning to write all of our applications in the procedural form, which means that we wrote all of our code in the main method. So that was the only code block that was controlling the entire application that we wrote. We wrote all of our instructions in the main method. That is procedural. Now, working around with methods, the method. Sorry, let me put it right. The main attribute of the classes that we did create is a typical example of a method. So, in trying to explain what methods are, methods are code blocks that are given names which perform a specific task. Okay, so let me write it here so then you can see it clearly. Code blocks, or it could be block or blocks with a given name, such that upon calling, they execute a specific task. So, like I said earlier on, the main method is an example. It has a name. In all of the code that we wrote, we gave the main method, and the main method has the name main, and it is the method that calls itself. So when it's called, it executes its content. Okay, so basically that is what methods are supposed to be. They have names, they have some other additional attributes, and when they are called, they execute the instructions or the tasks that are meant for it to be executed. Now we want to quickly look at the advantages, the significance of methods. What advantages would we gain having to use methods? Couldn't we have dealt away with the use of creation of methods? Why do we need to bother ourselves creating methods? Why should we not write all of our instructions in the main method, but possibly create some additional methods and then write our instructions in them? Okay, so the very first major advantage in having to use or write instructions deploying methods is that it is going to help that we're able to um, break the application into smaller units. Okay, so we're able to create smaller units. Now creating smaller units actually brings the application to a level of you being able to have a simple code. Okay, so at the bottom line you have a simple code. Now when you're also able to break your code into smaller units, because you have them in simple codes, it would also imply that there is easy readability. You have written your codes in block. They have names, so the names of the functions may even suggest exactly what that code block is supposed to do. However, if you wrote them all in that one big function, it becomes complex. Readability is a problem, and then it is very difficult for people to look at your code and easily understand. However, if you put them in smaller units, if you put them in functions, the code looks much simpler, and then it is easy to read. Okay, easy to read, and then let me add easy to read and or understand. Okay, and the advantage that we will get having to deploy methods, which is the key reusability of codes. Reusability of codes. Now, because the method has a name, and then you can call the method as many times as possible. Okay, you don't need to rewrite codes. Anytime that code block is relevant to be written, when you call the name of that method, quickly it's executed. So you don't need to repeat blocks of code over and over and over and over again, which is going to make your code bulky. Okay, so we are able to call the methods as many times as possible, and that makes them reusable. Okay, this is a very great advantage in having to write your codes using methods. And then also when you have an error, it becomes easy to debug. Why do we say this? Because if the error is from one function, you don't need to now pay attention to your entire script. You only focus on the method where the error is coming from, and that's it. However, if you wrote all of your instructions in the main method, you would have to pay attention to every other single line to be able to help you debug the errors that you have. However, if you have put them in smaller additional functions, then when there's an error, you focus on just that particular block, and then you are able to debug with ease. Also, when you put your codes in smaller units or in methods, you are able to provide some amount of security. Okay, so in subsequent lesson we'll be discussing encapsulation. Making methods private, helping you to make some variables even private. So it will determine how the variable's content is supposed to be accessed. Okay, they are not open to all of the procedures at all of the times. So these are the major advantages in having to write instructions in programming, falling on the use of methods. Now, I would want to quickly mention also that in using methods, you come across a method that has one of its access modifier to be void. If it is void, it means that that method is not supposed to return a value when it is called. Like I said earlier on, Methods are executed when they are what? They are called. Okay. So in an instance of a void method, the void method, let me write it. Void methods return no values, no value or values upon a call. Okay, it doesn't need to return any value when it is called. A typical example is what we have been using in our code. So when you root, for example, system.out.print or print line, and then he said hello. What happens here? We have passed on the string hello to the function print line. We are saying that they should print it out. Now when it is done printing this on the screen, that's it. The function ends out there. It stops execution because it is done printing printing hello on the screen. It doesn't return any value to any variable or to any function. Okay. Now a typical situation of a value return method. A value return method, it would in this case imply that when the method is called, it's supposed to pass on a value upon its call. Okay, a typical example is in the code block when we're using the wrapper classes. For example, integer dot pass int, and then you pass on a value, let's say 40. What are we saying here? Over here, okay, let's create a variable. Let's say int I is equal to this. So what we are saying on this line is that this is a typical example of a value returning method using the wrapper class to convert the string value 40. 40 now is put in double quote, which makes it what a string. So we're converting the string value 40 into an integer, and then when the method pass int is called, when it is called, it should return that result to the variable what I. Okay, so 40 will no more be a string, but will this time be a numerical value 40, and then it will be kept in what? In R. It will pass on to the variable I. So integer.parseInt as a wrapper class, it's a returnable return type. It's a value return method. It returns a value when it is what? It is called. That is much different from the function system.out.print. When it is called, it displays hello, or it displays its content in the string, and that is it. It ends over there. It doesn't pass on a value to any variable or to any method. However, the integer.parseInt, it takes a value and then it converts it, and then it passes on its result. So there is a result it's supposed to pass on after the conversion. That makes it what? A value return method. So these are the two distinct variations between a void method and then a value return method. So all the native data types, for example, the primitive or the native data types, for example, int, float, double, it's supposed to be 1b, double, long, byte, character, and then string. Data types all require that when used as an attribute for a method, the method would have to return what? Return a value. The only instance where it will return no value is when the method has one of its access modifiers as what? As void. As we will progress, we would make it. We will create, or we will learn to declare and then define a method where the attributes of the method will be revisited, and then practically you will get to understand the attributes of the method. All right, so quickly, in the very last section in this episode of the video, we're going to look at part of a method. Okay, so like we have been using, let me use the main method as an example. We give it attribute as public, static, void, main, and then we have the string array argument here. We have an open and a closed parenthesis. Okay, so now what we clearly want to understand is what are the parts of a method. Now the method has a header and has a body. Okay, so in a typical example of the main method, where is the header? Where is the body? Okay, so the top part here where I have highlighted is the header part of the body, and then the open to the closed parenthesis, and whatever will be written in here. So for example, if we wrote system.out.print sandwich friends. Okay, so from the open to the closed parenthesis, which includes the block, whichever instructions will be written within it, forms what? The body. So let me select it clearly. Well, from this bracket through to the side, okay, forms the body. The top here is the header. In some other books, they make reference to that as the signature of the method. Okay, so now let me explain once again what public, static, and then void represents. Public and then static is what will be referred to as the access modifiers. So public as an attribute to the method will define it that the method should be accessible within the class that it is put, and outside of that class, that method should be visible. Okay, it will as we move on, we'll be looking at instances where it is not public but it is private. Okay, all right. So static method, if the method has one of its attributes to be static, it will simply imply that the method does not need an instance of what? A class before it is executed. Okay, so let me put it here. Static means that the method does not need an instance of the class for which it resides to be invoked. Okay, so for the method to be called, it doesn't need an instance of the class for which it resides before it is invoked. So a typical example, if we put this main method in a public class, class, I want to call it, let's say, try-in. Let me take one of these parentheses, braces. I will drop that here at the button. Let me shift this slightly for readability sake. All right, great. So we have the class starting from here and then here. Okay, so because the main method is given its attribute as static, originally the main method does not need to be called before it can be executed. But every other method that the developer will create, it will need to be called before it's executed. Okay, so in the situation of a static method. Static, like I explained earlier on, it means that the method does not need an instance of the class. So we will not need to create an object for the class. So creating an object would have written trying, and let's say the object name is t new and then trying. With this, we have created an object t that will help us to make access to the properties of the class. So if they're to be non-static, what we're going to have done was to use the object t dot the name of what the method main. I have already explained that the main method needs not to be called before it's executed, but I'm using this as an example in here. If there to be any other ordinary method that has been created by the developer, then this is how it's supposed to be called. But like I explained earlier on, the main method needs not to be called before it is executed. This is typically just a hypothetical example that we're setting in here. Okay, so anyway, to do away with any kind of possible confusion, let me clear off this and then call this let's say add, so that no one gets any confusion in here. So we have a method, its name is add, and it is what, static. If it is static, we need not to create this instance of the class before we are able to execute it. However, if it didn't have its attribute as static, then what we will need to do is to create an instance of the class, like we have done on line number 36 and then 37. Sorry, 37 and 38, to have the object, and then we use the object to make reference to what, to the method, and then we are able to call it. Okay, so these are the very parts of the method. The method has a header, it has a body. We have explained also what public and then void is. If it is void, it means that when this method is called, it is not supposed to return a value. Okay, if it is were to be an integer instead of void, then what we need to write here is a return statement that is supposed to return an integer type, which is what, for example, 0. If it is not an integer but a float, we will say it's supposed to return 0.0. If it is double, how do you think it's supposed to be? 0.00. Oops, not O. Right, so the attributes here represent the return type. Okay, and then add is the name we are giving to identify the method. Okay, so these are the two major parts of the method: the header and then the body. And then we have also explained what goes into the header as attributes, and we have explained the content of the body. Thanks so much for staying on for this lesson. I hope to see you again in the next lesson as we look at how to call a method.